going to be doing Unit 1, Lesson 3, the close reading for energy transfer in collisions. We're going to be doing science. So, our focus activity is going to be this video talking about noticing and wondering. So you're just going to watch this video and you're going to tell me what you notice and wonder. Our definition also, I want you to think about this as well. This is what this is going to be. Energy transfer, the movement of energy from one object to another. You ready? Mm-hmm. That was called a Newton's cradle. What did you notice and wonder? Oliver, what did you notice or wonder?
So what the guy was doing.
Mm-hmm.
So he like grabbed one and then when he let go of it, it went back and forth and he did two. And then two of them went back and forth and then which one was going up? The extra one was it?
Mm-hmm. Yeah. Blake?
Like when he did one, all of them went and then the other side.
Yeah. So some of them moved and some of them didn't. Kaylin?
How many ever he pushed up went over on the other side? Like when
So like if he pulled one, how many went on the other side?
one or two, and the other one two went over.
Yeah. Ayana?
I wonder why he did this. Why did he wear nothing?
So why when he pulled one, only a few of them stayed there, didn't move? I like that you have some questions. Okay, we're going to move on. Our learning objectives today are apply what you know about the differences between elastic and inelastic collisions. You're going to repeat after me. You ready? Apply what you know about the differences between elastic and inelastic collisions. So we're going to be seeing these different things. Also, some of these pictures you're going to be thinking about too when we're going on. So you're going to just follow along with your eyes while I read this, okay? Give me a thumbs up if you understand. Very nice. Energy transfer is the movement of energy from one object to another. Newton's cradle is a toy that shows how energy can be transferred. When you pull one ball up and release it, it will collide with the other balls. As a result of the collision, the ball on the opposite end swings out. Then that ball swings back and hits the other balls, causing the first ball to swing out. Energy is transferred from the first ball to the last and back again because of the collisions. So, what is energy transfer? You're going to repeat after me. Energy transfer is the movement of energy from one object to another. What is Newton's cradle? Newton's cradle is a toy that shows how energy can be transferred. So what is the result of the collision? So as a result of the collision, the ball on the opposite end swings out
swings out.
Then that ball swings
Then that ball swings
back and hits
back and hits
the other balls,
the other balls,
causing the first ball
causing the first ball
to swing out.
to swing out.
How is energy transferred? Energy is transferred
Energy is transferred
from the first
from the first
ball to the last
ball to the last
and back again
and back again
because of collisions.
because of collisions.
Good job. Give yourself a round of applause. Beautiful, beautiful. Okay, I'm going to read this paragraph and then we're going to choral read, meaning that we're going to say it together. Do we understand? Give me a thumbs up. Okay, I'm going to read the whole thing first, then we'll choral read. Newton's cradle can be used to demonstrate an elastic collision. In elastic collisions, there is no loss of kinetic energy from the system. A system is a group of connected parts that make up a whole. The colliding balls in Newton's cradle act as a system. Do you know what choral reading is? Ayana.
Where you stop, like, on a sentence, or like a couple words, and then you read it first, and then you read it later.
Yes. But I'm going to add to that. So we're going to all read it together. Understand? Okay. Starting here, we're going to read it all together. Newton's, say it with me. Newton's cradle can be used to demonstrate an elastic collision. In elastic collisions, there is no loss of kinetic energy from the system. A system is a group of connected parts that make up a whole. The colliding balls in Newton's cradle act as a system. So you're going to turn and talk, and I want you to turn. You're going to have your group just talk. You guys will talk. You guys will talk. You're going to turn and talk. What does the Newton's cradle demonstrate? Looking up there, what does the Newton's cradle demonstrate? What does the Newton's cradle demonstrate? When you're ready, put your finger on your nose. When you're ready, put your finger on your nose. Like that this group talked and have their finger on their nose. Who would like to tell me, what does Newton's cradle demonstrate, Ayana?
Elastic collision.
Yes, our first sentence. Newton's cradle can be used to demonstrate an elastic collision. You're going to turn and talk again. What is a system and an example of it? What is a system and an example of it? What is a system and what's an example of it? When you're done, put your finger on your nose. I love how Veronica did it right away. What is a system and what is an example of it? Please raise your hand when you have an answer. Kaylin, what's a system?
A system is a group of connected parts that make up a whole.
Very nice. Do you know what an example of it is?
The colliding balls in Newton's cradle act as a system.
Perfect. Thank you. Good job. So for this one, you're going to swap off. One person will read one sentence, the next person will read the other sentence. You're going back and forth with your group. When you're done, you're going to stand up. Ready? Go. You're reading, one person reads the first sentence, the next person reads the next sentence. You go back and forth.
Every time the ball decreases.
But some of the energy
When you're done, stand up. When you're done, finish reading.
Over time, the ball decrease in height and will eventually stop. Some changes from one. Yeah.
Where are you guys at?
Stop. Wait, yeah, some.
Okay.
Mm-hmm. Energy is transformed when it changes from one form to another.
Okay. Thank you for telling me you're done. You can sit back down. You're going to turn and talk. If the collisions in Newton's cradle were perfectly elastic, what would happen? Look at our first sentence. If the collisions in Newton's cradle were perfectly elastic, what would happen? When you're ready, put your hands on your head. Who would like to tell me if the collisions in Newton's cradle were perfectly elastic, what would happen? Corbin?
The balls would continue to bounce up and down forever.
Yeah, exactly. If it was perfectly elastic, they would bounce off of each other constantly. They would never stop. They just keep bouncing. I'd like you to give me a thumbs up or thumbs down. You're going to look at our paragraph here. Is Newton's cradle perfectly elastic? Thumbs up or thumbs down? Is Newton's cradle perfectly elastic? Thumb up, thumb down. Who would like to tell me? Is it perfectly elastic? Yes or no? Zoe?
It's not perfectly elastic.
How do you know that?
Because the balls, over time the balls decrease in height and will eventually stop.
Exactly. We're talking about if it was perfectly elastic, what would they do? Corbin?
The balls would continue to bounce up and down.
Yeah, they just keep bouncing, but it's not perfectly elastic, and you saw how it slowed down and it didn't keep bouncing off of each other. I'd like you to turn and talk again. What happens to some of the energy from the Newton's cradle? Looking up there, you'll find it. What happens to some of the energy from the Newton's cradle? When you're ready, put your hands on your head. We're fast this time. What happens to some of the energy from the Newton's cradle? Kaylin?
Then Newton's cradle transformed into sand and each time the ball collides.
Yes, exactly. Could you hear like a little clicking sound when they were hitting each other? Yeah, and the heat was transferred from back and forth from the balls. So, we're going to do the same thing with your group. You're going to go back and forth. One person reads a sentence, then the next person reads a sentence, so everyone has a turn. Ready? Yes, please. Or if you want one person, if you only have two people in a group, you could just do one person does one paragraph, the other one does the other one. Okay, start when you're ready. Stand up.
Think about a car hitting a brick. Oh.
Got one group done?
It's right here.
The car is reduced into
Portion of the car
Movement
movement is
converted,
converted into energy that
crushes
crushes the
metal.
metal part of the car.
This is also kinetic.
Good job. Okay, you can sit back down. You're going to turn and talk. In an elastic collision, what happens? In an inelastic collision, what happens?
Think about a car
In an inelastic collision, what happens? When you're done, put your hands on your mouth. Got two groups done. In an inelastic collision, what happens? Who would like to tell me, in an inelastic collision, what happens? Corbin?
Some of the kinetic energy is transformed into sound and heat.
Look up here. You're close. Read this part. Some of the kinetic energy
Of the colliding objects is transformed into other types of energy.
Yes, so inelastic is some of the energy. When they're colliding together, the objects are transformed into different types of energy. When a car hits a brick wall, what happens to that energy? Turn and talk.
All transformed.
It should be up there. When you're done, put your hands on your mouth. When a car hits a brick wall, what happens to the energy? Please raise your hand. Do you know the answer? Blake.
The kinetic energy of the car reduced to zero.
Yeah, the kinetic energy of the car is reduced to zero. When it hits that wall, is it still going?
No.
No, it's stopped. It's at 0 miles per hour. It's not going anywhere.
Don't you like smash?
So you're going to do this. You're going to turn and talk. And then you're going to put your hands over your mouth. You're going to find in the text, what does the kinetic energy turn into? When you find the answer, 2 hands over your mouth. Hands over your mouth when you got it. So there should be 2 things that it turns into. Do we see that? Some of the kinetic energy transforms into, put your hands over your mouth, Corbin. You're going to tell me when I count down to 1, what are the 2 things that the kinetic energy is transformed into? Ready? 3, 2, 1.
Sound and
heat. Sound and heat. Thank you very much. Okay. I'm going to read this first paragraph. I want your eyeballs to follow along with me. An inelastic collision is a special kind of crash where nothing is lost. Both energy and motion are kept the same before and after the crash. So close your eyes. Everyone close your eyes. Picture this in your head. Imagine two bouncy balls hitting each other and bouncing off without getting squished or slowed down. That's what elastic collision is like. Open your eyes now. You're going to turn and talk. Have you ever seen two objects that collide together but do not break or smash, slow down, or squish together? Have you ever seen two objects that bang together but nothing breaks or squishes? Nothing. Okay, stop, partner. Give me an example.
Yeah, the video, but it slowed down.
When you're ready, put your hands on your desk. Both hands, zero voice, looking up here when you're ready. Who would like to tell me an example of two objects that collide together but do not break, smash, slow down, or squish, Corbin?
Two chairs.
Two chairs, they bang together, yeah. What else? Did we see an example at the beginning of this whole lesson?
Yeah.
I heard Kaylin, what was it that you were talking about? I heard you say something.
The video.
Yeah, the Newton's cradle. What did you see?
We saw how when you put one or two how many up, they go on the other side and it keeps going for a while.
So those balls, do they smash and break?
No.
No, what do they do?
They just keep going and don't.
What is this called when they're hitting each other?
70.
Yeah, but what is this called? They're bouncing off each other, right? They're smacking into each other and they're moving, but nothing's getting broken. Okay, now close your eyes. Here's an example. Picture this in your head. Billiard balls hitting into each other on a pool table. Think about that. When those little pool balls, the billiard balls, they smack into each other, nothing's getting broken. You're staying the same. Open your eyes. That is elastic collision. In conclusion, a perfect elastic collision is something scientists use in physics that with problems to make things easier, but it doesn't happen exactly like that in the real world. So, we know what elastic collision is. We could think about that idea. We talked about it with our groups and it's in our head. Now we're going to talk about inelastic collision. Inelastic collision is a type of crash where some energy is lost. It might turn into heat, sound, or things getting bent or squished. But even though energy changes, the total motion or momentum of everything is still the same before and after the crash. So close your eyes. You're going to picture this in your head. Kaylin, put the book away. Picture a car smashing into a wall. What do you see in your head? That's what you're thinking about. What do you see in your head when this car is smashing into a wall? Saying it's going like 80 miles per hour, super fast. Close your eyes. Open your eyes. What do you see? Oliver, what do you see?
So the car's going at 80 miles per hour. The person who's driving it is to go, they can't reverse reverse that fast, but if they're going forward,
What do you see when the car hits the wall though?
so it's doing 80 miles per hour, so when it smashes, the guy has the airbag deployed, and also, like, pretty much the whole front gets destroyed.
The whole front gets
Yeah,
destroyed.
it's like flat.
I remember we learned last week, should we be wearing something while we're driving?
Seatbelt.
Seatbelt. I'm gonna have a seatbelt. Is there anything else that you saw in your head, Blake?
The car stopped.
The car stopped, yeah. Corbin?
Like the whole entire front, like the metal bent
Mm-hmm.
until it went like in through the engine, and then it went into her seat.
Oh, okay, so smashing into their seats, that's what you're thinking? Ayana?
The person, like, it, because they weren't wearing their seatbelt.
Okay, if they weren't wearing their seatbelt,
It, like, they would get hurt, because of the glass, and they would, like, fly out.
yeah, they'd fly out and probably hit that wall. So you're gonna turn and talk, and you need to think of two objects that collide together that break, that now break, smash, or slow down, or squish. Talking to your partner. There are two objects that are hitting together that break, smash, slow down, or squish.
Drop the glass.
When you're ready, put your hands on your desk and your eyeballs are on the screen. Hands on your desk, eyeballs up on the screen when you're ready. So I know you're ready. Corbin, are you ready?
Yeah.
Show me that you're ready. Thanks, Corbin. Appreciate it. So who'd like to tell me an example? Bailey, what's an example? Two buildings, like falling onto each other? Okay, and then breaking? Okay. Kaylin?
Put two glass, like cups or like glasses next to each other, and they'll smash.
Okay, so like banging them into each other and they'll break? Yeah. Corbin?
Two planes.
Two planes hitting each other? Okay. Oliver?
Two cars smashing
Two cars smashing
into each other.
into each other?
Car hitting a wall.
Car hitting a wall? Ayana?
Two basketballs.
Two basketballs hitting each other? Okay. So now I want you to close your eyes. You're going to imagine this one more time. Closing your eyes. Think about having a vase, a glass vase in your hand. And dropping it on the ground. What do you see in your head? What is happening? I just pick it up above my head and drop it on the ground. Open your eyes and I'd like to know what you see. Bailey? Okay, yeah, maybe. Dropping it. Glass shards. Ayana?
Like a piece of glass and little shards of the glasses everywhere.
Mm-hmm. Corbin?
A really expensive vase.
A very expensive vase, yeah. Is it breaking or is it staying, if I drop it, is it gonna stay together?
Yeah.
No. But yeah, I just wasted a bunch of money on that vase. Blake? Yeah, it didn't bounce back up. It fell and just crumbled. Kaylin, anything else?
Yeah, because I saw how when you dropped it, it went and it smashed hard on the floor and broke into lots of pieces.
Mm-hmm. You could see it in your head. That's good. I'm glad. So, in conclusion, elastic collisions are things that don't bounce perfectly. Some of the energy goes into making noise, heat, or changing shapes. When I drop that vase, do you think you'll hear something?
Yeah.
Yeah, you'll probably hear what?
Crash.
A crash, yeah. Broken glass all over the ground. Okay, again, I want us to say this together. We're gonna choral read this together. Our learning objectives. Ready? Apply what you know about the differences between elastic and inelastic collisions. Beautiful. Oh. I want you to describe to me what you would see and hear during a car crash. So think about it. Talk to your partners. What would you see and hear during a car crash? Okay, raising your hand, what would you see and hear? Kaylin, what would you see and hear?
A big crashing sound.
You hear a big crash? Oliver?
So what you would hear is probably like glass breaking and whatnot, and what you would see is pretty much a destroyed car.
Seeing a destroyed car?
People getting hurt and sound of explosions, because if it's a semi-carrying oil and the car's on fire, it will ignite and open.
Okay, so explosions, and what else did you say?
Lots of people getting hurt.
Okay, let's not have that, that's not very, but good to know, good to know. Corbin, what do you hear or see?
I see I see a ruined car.
A ruined car?
No, because that would go with destroyed car.
A what?
That would
Destroyed, okay, same thing, okay. Yeah? Zoe?
You hear sirens?
Sirens,
Yeah.
like cop cars,
Yeah.
fire truck.
ambulance, fire trucks. Yeah,
Like if you were in the car crash, like your sound would go like gone.
so if you were in the car crash, you'd say you wouldn't really hear anything? Okay.
Yeah.
Like if you're in, okay, in,
Yeah.
car crash. Let's say
Can't hear.
temporarily, let's just say deaf. I mean, yeah, temporarily you might be really fast. Okay, I'd like you to get out your whiteboard. If you do not have a marker, please grab one from up front. How do you know energy was transferred based on what you see after a car crash? So after you see your destroyed car, how do you know energy was transferred based on what you see after a car crash? So split your board into half. So look, it should look like this. This is your board. Split it in half. So there's going to be two different things. Yep, perfect, Corbin. Thank you for showing me. Beautiful. So on the left side, you're going to put, how do you know energy was transferred based on what you see after a car crash? How do you know energy was transferred based on what you see after a car crash. I'm going to give you about a minute. Yes, Alan? How do you know that energy was transferred when there was a car crash? So on one side, yep, on the left side. You got about 30 more seconds. Please do not draw on your board.
How do you know that?
Look up there, it says it right there. How do you know that energy was transferred based on what you see after a car crash? How do you know that energy was transferred? Or what was it transferred into? When you see it, how is it transferred? My second one is how do you know energy was transformed based on what you hear after a car crash? After you have your answers down, I'd like you to turn and talk, but I want you to have those answers down first. How do you know energy was transformed based on what you hear from a car crash?
On the bottom line, is it on the right side?
Mm-hmm.
So we're saying like what you hear?
Yeah, so what you heard, how was it transformed?
You mean
How was the energy transformed? What did it turn into?
Can we do one word?
Sure. Who figured out your answers? Okay, Corbin. Looking up there, how do you know energy was transformed based on what you hear during a car crash? When you're done, you can talk to your group. So Corbin, you can talk to your group and tell them what you got. When you're done, talk to your group. So you guys can work together to see if you can figure out your answers. Do not erase your board, leave your board how it is, because I'd like to look at it after we're done.
Like all the cars get slower because they're not moving after they crash. So like we can't use the tires always off the rims. So we can't move.
I'm going to give you one more minute, finishing up, talking to your people around you. Everyone needs to have something on both sides of their board. Corbin's helping you too. That side is this one. How do you know energy was transformed based on what you hear? No, you have one on one side and one on the other side. You have two answers. That's why it's cut down the middle. One of them's about how energy was transformed when you see it, and the other one is about hearing it. Seeing and hearing. Two different ones. $30 more seconds. Everyone needs to have something on their board.
hear.
Yeah. I don't know what the word's
How do you hear?
No.
Like using your hearing?
Yeah, but what's the word for it?
Hearing, that's all I could think of. When you have your answers, you should have talked to your group. So flip over your board when you're all done. Hands on your head in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so what do you see and hear during the Newton's cradle? What did you see and hear for that one? What'd you hear? Corbin, what'd you hear?
Like the marbles colliding.
You could hear them colliding?
Yeah.
Blake? Bouncing off of each other? So I'm gonna say this is the same thing. But you saw it, marbles bouncing off of each other.